start? Well, good morning, ladies and gentlemen. I have the amazing opportunity to tell you something about our research. My name is Lubomír Štěpánek, and I'm coming from First Faculty of Medicine, Charles University in Prague, and from Faculty of Biomedical Engineering, Czech Technical University in Prague. Me and my team is interested in, let's say, facial attractiveness evaluation for purposes of plastic surgery. Let's have a look at the intended outline of the talk. I will start with a quick introduction when I'm going to say something about some basic terms. Then I will follow with the developed methodology. I will go on with some results we have got, and finally I will make some key findings at the end in the summary. Well, there are plenty current studies that come to conclusion that human facial attractiveness is data-based and is irrespective of the eye of perceiver, and that's the reason that it is feasible to just explore on which geometry features of human face affect the attractiveness of a human face the most. Yeah. The field of plastic surgery should also take consideration into the fact that the total face impression is not dependent only on total appearance, but also on a presently expressed facial emotion. And there is, in fact, no face without facial emotion at all. Yeah, there is also some kind of emotion if you just take a picture of a face, human face. Well, in this study, we just apply some methods of machine learning to, let's say, identify some geometric features of a face which are associated with an increase of facial attractiveness just after undergoing rhinoplasty. When rhinoplasty is one of the most common surgeries of plastic surgery, and it's just a surgical correction of shape of nose. Yeah, and furthermore, we tried to explore how accurate the classification of faces into some sets of facial emotions in fact is. Well, in case of facial attractiveness evaluation, we just collect some profile facial image data for each of a patient before and after rhinoplasty. The collected image data were processed, they were landmarked. It means that some important facial points were plotted on the pictures. They were after that they were post-processed, and multivariate linear regression was performed to select some predictors which are associated with, let's say, increase of attractiveness after undergoing rhinoplasty. In case of classification of face data into facial emotions, the process is pretty similar to the previous one. Some portrait facial image data were collected. There is an exception that, for example, for each person was exposed to emotion insective, and image where they are processed, landmark analyzed in the same way, and biased naive classifiers, regression trees, let's say rather decision trees, and neural networks using backpropagation and sigmoidal activating function were learned to allow assigning into one of defined class of facial emotions. Well, the facial attractiveness of patients was measured using a 7-point Likert scale by a large board of independent observers. It means that they use numbers like -3, -2 to +3 just to assess an attractiveness level of an observed person. Image of such a person. Well, and the set of used facial emotions is based just on Ekman-Friesen FACS scale. It means facial active coding system. It was improved a bit because we just assign a quality of each of emotions, just in a way to be positive, neutral, or negative one. Yeah. Landmarking, as I said before. Landmarks are morphometrically important points on the plane of an image. They were collected using developed Shiny apps on our own, and after that they were transformed into coordinates. And in the end, they were just normalized by the terms of reduction into range 0 to 1 to make the two different pictures, just make them comparable. Well, if we got landmarks and their coordinates, we were able to define some expert-defined metrics or angles. For example, nasofrontal angle is just an angle between landmarks 2, 3, and 18. It's somewhere here on the profile picture. Or nasolabial angle is an angle between landmarks 7, 6, and 17. And so on. It's just an expertise metrics. Well, after undergoing the rhinoplasty, we can expect an average increase of facial attractiveness to be about, let's say, 3.8 Likert point, and per each radian of nasofrontal angle, it is about 0.35. And for nasolabial angle, it is just about 0.4, and so on. These are the significant predictors. Card decision trees can show us which of the predictors just affect the classification into emotions the most. In this case, we can see that it is angular height. It means it is a distance, vertical distance from mouth angular to horizontal line between the lips, and if it is large enough, it means that the face is smiling. An emotion is classified as a fun, and it sounds quite logical. Yeah. There are some, let's say, confusion matrices for some of the methods that were learned. The first one is for naive Bayes classifier. The second one is for decision trees. The last one is for neural network. And we can assess an overall predictive accuracy. It is about 65% for the naive Bayes. It is about 70% for the decision trees, and it is about, let's say, 75%. It's quite good for the model for the neural networks. Well, as I said, as we said before, enlargement of both nasolabial and nasofrontal angles seems to be significant predictors for increasing facial attractiveness. Then neural networks manifested, as we can see, the highest predictive accuracy in case of classification into emotions and geometrical shape of mouth, then eyebrows and eyes, just in this descending order, affect the classification into emotions. Well, okay, thank you for attention, and I can try to answer your question if any. Okay, thank you.
Yeah, we'll leave that. Yeah. So we'll just hand over to the next speaker there. A round of applause, and we'll just get Johannes set